Chapter 9 Concept Check Answers. 1a. What is a differential equation? It is an equation that contains an unknown function and one or more of its derivatives. Part B. What is the order of a differential equation? It is the order of the highest derivative that occurs in the equation. Part C. What is an initial condition? It is a condition of the form y of t sub naught equals y sub naught. Question 2. What can you say about the solutions of the equation y prime equals x squared plus y squared? Just by looking at the differential equation. The equation tells us that the slope of a solution curve at any point open x and y close is x squared plus y squared. Note that x squared plus y squared is always positive except at the origin, where y prime equals x squared plus y squared equals 0. Thus there is a horizontal tangent at open 0 and 0 close, but nowhere else, and the solution curves are increasing everywhere. Question 3. What is a direction field for the differential equation? Y prime equals big F of x and y. A direction field or slope field for the differential equation y prime equals big F of x and y is a two-dimensional graph consisting of short line segments with slope big F of x and y at point x and y. Number 4, explain how Euler's method works. Euler's method says to start at the point given by the initial value and proceed in the direction indicated by the direction field. Stop after a short time, look at the slope at the new location, and proceed in that direction. Keep stopping and changing direction according to the direction field until the approximation is complete. Number 5. What is a separable differential equation? How do you solve it? It is a differential equation in which the expression for dy over dx can be factored as a function of x times a function of y. That is, dy over dx equals g of x f of y. We can solve the equation by rewriting it as open bracket 1 over f of y close bracket dy equals g of x dx, integrating both sides and solving for y. Equation, number 6. What is a first order linear differential equation? How do you solve it? A first order linear differential equation is a differential equation that can be put in the form dy over dx plus big P of x times y equals big Q of x, where big P and big Q are continuous functions on a given interval. To solve such an equation, we multiply both sides by the integrating factor, which is big I of x equals e to the power of the integral of big P of x dx, to put it in the form of open big I of x times y close prime equals big I of x, big Q of x. We then integrate both sides and solve for y. Part 7, number 7a. Write a differential equation that expresses the law of natural growth. What does it say in terms of relative growth rate? If big P of t is the value of a quantity y at time t, and if the rate of change of big P with respect to t is proportional to its size, big P of t at any time, then d big P over dt equals k big P. In this case, the relative growth rate 1 over big P times d big P over dt is constant. Part B. Under what circumstances is this an appropriate model for population growth? It's an appropriate model under ideal conditions: unlimited environment, adequate nutrition, absence of predators and disease. Part C. What are the solutions of this equation? If big P of 0 equals P sum naught, the initial value, then the solutions are big P of t equals big P sum naught e to the power kt. A, number 8a, write the logistic differential equation. The logistic differential equation is big P of d big P over dt equals k big P open 1 minus big P over big M close, where big M is the carrying capacity. Part B. Under what circumstances is this an appropriate model for population growth? It is an appropriate model for population growth if the population grows at a rate proportional to the size of the population in the beginning, but eventually levels off and approaches its carrying capacity because of limited resources. Equation 9, number 9, part A. Write Lotka-Volterra equations to solve to model populations of food fish, big F, and sharks, big S. D big F over dt equals k big F minus a big F big S. And d big S over dt equals negative r big S plus b big F big S. Part B. What do these equations say about each population in the absence of each other? In the absence of sharks, an ample food supply would support exponential growth of the fish population. That is d big F over dt equals k big F, where k is a positive constant. In the absence of fish, we assume that the shark population would decline at a rate proportional to itself. That is, d big S over dt equals negative r big S, where r is a positive constant.